Dear student, warm welcome to NPTEL 2 video course on Geosynthetics Engineering in Theory and Practice. My name is Professor J. N. Mandal, Department of Civil Engineering, Indian Institute of Technology, Bombay, Mumbai, India. The name of the course, Geosynthetics Engineering in Theory and Practice, lecture number 26. This module 6, lecture 26, Geosynthetics for reinforced soil retaining wall. The outline of this course, part 1, mechanically stabilized reinforced soil retaining wall with modular block or panel facing. We will cover introduction, geosynthetics reinforced soil wall system, different precast concrete modular block or panel facing and connection, analysis and design procedure for geosynthetics reinforced soil retaining wall, cost consideration, construction procedure for precast concrete face wall, submission of material and test report by manufacturer, design critiques, failure of structure and tolerance. Part 2 will cover GeoTextile or Geogrid wrap around face mechanically stabilized earth or MSE wall. This will cover general design of GeoTextile wrap around face wall, wrap around face construction detail. And part 3, Gravion wall. General then Gravion wall design, reinforced soil Gravion wall design and feasibility study on fly ash as a backfill material and also the geocell wall. Part 1, mechanically stabilized segment reinforced soil retaining wall. So, you know that basic concept with consist soil mechanics and the polymer material, then application to the reinforced fill application. We have covered for the design and analysis for the unpaved road, which is short term reinforcement strength required, which longevity may be 5 to 15 years. Now, we will discuss the reinforced fill application in case of the retaining wall, reinforced soil retaining wall. And this is the long term reinforcement strength required and is service lifetime is excess of 75 to 100 years. So, different types of conventional rigid retaining structure made of masonry and concrete are available to resist the lateral pressure. You know, gravity retaining wall, semi-gravity type retaining wall, cantilever retaining wall, counterfort retaining wall and bridge and abutment, anchorage sheet pile, soil laying and braced excavation. You can see this is the gravity wall and this is the plane of concrete and this is the backfill material and this is the plain concrete masonry. This is the conventional system. Same semi-gravity wall, this is the reinforcement material and this is cantilever wall. Here is the forcement, there is the stem, here is the back face, here is the heel, this is the front face, this is the toe is there. So, this is the cantilever wall. This is counterfort wall. So, you know these are the conventional reinforced soil retaining wall. Also bridge and abutment what this is the bridge desk, this is the approach slab where we adopt the kind of the concrete structure. Also the anchor sheet pile what we use for the soil nailing in a slope, you can use for the braced excavation for any underground structure. So these are all conventional material or the system. Now that how the geosynthetics has come into this picture. A tremendous number of the geogrid or the metallic reinforcement wall have been constructed in the past 40 years. Because you see that what will be the difference in the cost of the conventional reinforced concrete retaining wall system with the traditional or the newly reinforced mechanically reinforced soil earth system. If we can compare, you can observe that there is a differences in terms of the cost and in terms of the time. So you can convince to the agent that this is more economical and you can complete the structure with a very short time, and the differences in the cost can be equally shared by the contractor and the client. So this is one of the very effective vehicle for the introduction of any kind of the new product or the concept like the GeoGrid or the GeoTextile reinforced soil system. Now here the inclusion of the reinforcement in soil is not new. It has been used in biblical case. The concept of the reinforced system is well established, and this is the some of the component parts of the key dimension of the reinforced earth wall, which is the Biddle vision, Biddle 1966, who has used the metal as a reinforcing material. And here you can see this is the metal, very steep, it acts as a reinforcement, and this is as a facing element, and it can be placed vertically and also the horizontally. That means we are to calculate what will be the vertical spacing between the two reinforcement and the horizontal spacing between the two reinforcement, and this is the strip that with this W and thickness is very, very less. So this is the facing element right hand side, Lee TL 1973, and this is the precast concrete panel, and this is the reinforcement, metallic reinforcement. So this kind of the structure have been completed and it has been used exclusively around the wall. So traditional concrete and masonry gravity wall or the cantilever retaining wall are almost obsolete due to the higher cost of construction. Reinforced soil wall is the best cost effective solution. Metallic strip or geosynthetics can be used as a reinforcement. Geosynthetics is an emerging, bona fide emerging construction material around the wall. The mild steel degrade due to the electrochemical corrosion, whereas polymer materials suffer from creep problem, causing the reduction in the ultimate tensile strength. Therefore, adequate factor of safety should be considered to meet the serviceability limit. There are many disadvantages of using the metallic strip in mechanically stabilized reinforced earth wall. This high cost, long-term susceptibility to corrosion, protective coating can reduce the corrosion, but it is uncertain in the field due to the groundwater or electric current. Sustainability depends on the correct choice of the backfill material, gradation, chemical property. This is very important, that what kind of the material you choose, and we should sustain, we should meet the certain criteria as per the specification. It cannot be used with many indigenous material, and backfill material cost is about 85% of the total cost of the reinforced soil wall. In generally in India, it may be about 25 to 30% of the total cost of the reinforced soil wall. Geosynthetics reinforced soil wall system, it has an advantage because polymer do not corrode, it is economical, used with many indigenous material, more deformable than the metal reinforcement, long term durability. The geosynthetics is flexible, you can move any direction as you like it, and unskilled labor can place it. You do not need any skilled labor for this, and you require minimum excavation, it gives good drainage, and heavy equipment is not needed. You can see here the different types of the geosynthetic reinforced soil structure. Here the geosynthetics is wrapped like this, wrap around face. So you place the geosynthetics and wrap it, and you fill up with the soil and compact it and wrap it, you can construct the geotextile wall, reinforced soil wall. And because you cannot keep these geosynthetics in the open sunlight due to the ultraviolet or vandalism, you can spray some shotcrete or asphalt here to prevent it from the UV light. Here this is the concrete as a panel, and this is the GeoGrid as an reinforcement material has been used. Here it is as a block, you can see this block, which is GeoGrid is connected with the block, and you can construct a reinforced soil wall. Here also is the retaining wall, and this is the reinforcement, and this here is the anchoring. So there is a passive resistance will act. So you can reduce the thickness of the reinforcement by introducing this anchor, so which can provide with a good passive resistance. Also geosynthetics material can be made of fiber reinforced backfill, only filled with the fiber reinforced backfill. You can use also fiber reinforced backfill. You can use also the superlight material, that is geofoam, and you can provide with the drainage also back. You can provide with the cellular reinforcement and the GeoGrid material. The cellular reinforcement will act as a facing element, or you can complete this reinforced soil wall only using the cellular reinforcement. You do not require any GeoGrid material. Also superimpose or tire wall. You can construct one wall and then make a slope and make the another wall. It is superimposed, or it is called the tire slope, and this also uneven unreinforced soil wall. You can see that length of the reinforcement is less, then gradually increasing like this, little bit trapezoidal in shape, and this is the depth of the embankment, and this is after FHWNHI 10024/2009. So different types of the systems of reinforced soil wall can be constructed. You can see here also the overall base with the large. This is the S of M, and this is the LL on the left hand side of the reinforcement. This is the right hand side of the reinforcement, and this angle is 45 degree plus pi by 2, and this is the height of the wall HL on the left side, this HR on the right side, and it should not sometimes the overlap. So overlap base with is large. So you could provide this SM value, and SM value should be 0.5 times the height of the wall. That means this SM should be 0.5 times the height of the wall. This overlap base width is required. Sometimes you can say overlapping of the reinforcement when there is no space and you require to overlap the geosynthetic material. This is called back to back wall, and whereas this is the left hand side of the wall HL, this is right hand side HR, and this overlap is equal to L0. This L0 should be greater than 0.3 times the height of the wall, and L of R, this length, this is on the length L of R, L of R divided by H will be equal to, this is LL, L by L H is equal to 0.6. So, overlap length L0 should be greater than 0.3 H, and LR by H is equal to LL by H will be equal to 0.3. So, this is after FHW NH1 10024 2009. So, you can use that geosynthetic material either as a overlap base width is a large, what you should require, what is the SM value, and when it is the overlap with the reinforcement, and what should be the overlap length should provide. Now, this is stable feature of the wall. You can see here, this is the height of the wall, and this is the length of the reinforcement, and this is the rock here, the stable rock face. So, you cannot go behind this. So, this is the length of the reinforcement at the bottom, and this is the length of the reinforcement LT at the top. So, you can increase the length of the reinforcement at the top, and you can reduce the length of the reinforcement at the bottom. So, this is stable feature wall also can be constructed. This is as per FHW 2009. Also, influence of surcharge for tarred wall. You can construct the tarred wall. Number of tarred you can construct after CIMIC 1900. This is the wall, this is the number of the reinforcement, and this is 45 degree plus pi by 2. Then you make a slope here, and then you can construct another wall where there is a surcharge load also. So, that should be a certain distance, this distance. So, where you can, you will be able to require proper design for the surcharge for tarred wall. You see that some of the useful use of the reinforced soil retaining wall, and when you want to construct a vertical wall, you can provide the reinforced soil wall, and you can construct the building here. So, there will be no problem, and the bottom one that there will be a road, the car can pass through this area. Also, when there is a slope, you can use this Gravion and also the parallel layer of the GeoGrid reinforced soil retaining wall. We will design this also later, how you have been designed this Gravion reinforced soil retaining wall only with the Gravion, and as well as Gravion plus this GeoGrid reinforced soil, GeoGrid reinforcement material. In case of the waterfront structure, you can see this is the water table, and then you can construct the reinforced soil wall, and this is the layer of the number of the layer of the reinforcement layer. So, in the past 40 years, a tremendous number of the geosynthetics reinforced soil wall have economically been constructed around the wall. The geosynthetics reinforcement are placed horizontally in the retaining wall backfill. Geosynthetics reinforced soil mass are basically gravity structure resisting the earth pressure developed behind the reinforced soil zone. The fascia resists the mass of the reinforced soil, retained soil and surcharge load. The geosynthetics reinforced soil wall are flexible, therefore, it can tolerate the large settlement and earthquake loading than the conventional retaining wall. The ground improvement can also be avoided. You can see that different component of the reinforced soil wall. Here we will show that you can see this is the foundation soil. If the foundation soil is very poor, and how we can improve the soil, that also we will discuss. And this is the reinforced zone soil. This is the reinforced zone soil, and this is the facing element, and this is the backfill or the retained zone, and this is the reinforcement, GeoGrid as a reinforcement, and this is the drainage. This is the drainage you can provide at the back of the reinforced soil wall, because if there is a development of hydrostatic pressure, then this should be provide the proper kind of the drainage, is preferably with the incline. The water can pass through drain and it can pass through this and this to toe. This is the leveling pad, and you can provide also sometimes the geocomposite or the geotextile material. Here we wanted to focus that what are the various components in geosynthetic reinforced soil wall. When we are talking about the geosynthetic reinforced soil retaining wall, and then we should know what are the main components. Here there is a surcharge load, or if there is any live load, that also you have to take into consideration into the design. But you should aware about most of the components. I am saying you all the major component of reinforced soil wall. First is the foundation soil. It is required to improve the foundation soil by introducing the reinforcement layer. Or you can use geocell, or you can use prefabricated vertical drain, or encased stone column, and check the factor of safety against the bearing capacity failure. You can provide 2-3 layer of the GeoGrid reinforced soil wall, or you can provide with the geocell, GeoGrid geocell to improve the ground. So different kind of the improvement or the modification of the soil can be adopted dependent upon the side of the project. And you should know what will be the characteristics of the soil, and based on that we have to be select which should be the more economical and what kind of the system can be adopted for the improvement of the bearing capacity, and you check up what will be the factor of safety against this bearing capacity. So now the reinforced soil. The reinforced soil is the combination of soil and the horizontal layer of geotextile or the geogrid. It is preferable to use CEG less than 30 millimeter mole oblique kg, and molecular weight should be greater than 25,000 gram per mole for good quality of PET resin. When you talk about the reinforced soil, this is the reinforced soil zone where you are using the soil and the geogrid material. So you should know that what exactly that kind of the geogrid it is. So that's why this criteria it should satisfy that this what will be the value of CEG, it should be less than 30 millimeter mole per kg, and also at the same time what will be the molecular weight that greater than 25,000 gram per mole. So this will can satisfy the criteria that for the reinforcement that you can accept this as a geogrid material for the reinforcement. And the backfill soil is located behind the reinforced soil zone. This is the backfill soil, this is the reinforced soil zone. Now drainage field, this is also very important. I showed you the face drain behind the wall fascia, blanket drain beneath the reinforced soil zone, and back the chimney drain behind the reinforced soil zone. To prevent the build-up of hydrostatic pressure, drainage outlet must be connected to the collection pipe. Now polymeric geogrid or geotextile. Polymer geogrid and polyester strip, both flexible and stiff, are usually used as a horizontal layer. Also geocomposite reinforcement or hybrid reinforcement. There are also a lot of hybrid reinforcement or geocomposite. It is a geogrid laminated with the woven and non-woven geotextile material, which can be also used for the construction of the reinforced soil retaining wall, because the geogrid will take care for as a reinforcement function, whereas the geotextile, either woven and non-woven geotextile material, will act as a good drainage material. So geosynthetics mechanically stabilized reinforced soil wall can be constructed using the hybrid reinforcement or the geocomposite reinforcement. Now, geotextile, it may be the woven and non-woven, are also used wrap around face mechanically stabilized earth wall. So, you do not need that any facing element like the GeoGrid where you wanted to use this kind of the panel or kind of the block. Instead of that, in case of the geotextile, whether it is a woven and non-woven geotextile, you can simply wrap the face element. So, you can construct this wall. Now, fascia, the facing have authentic views and can be of any shape and color. So, many aesthetically pleasing facing design are also possible. So, there are different types of the facing element which I will just shown, that wrap around facing, segmental precast concrete panel, full height concrete panel, modular block wall, Gravion facing, timber facing, welded wall mesh facing and gunny bag facing and brick facing. So, you can see that how the different types of the facing element can be constructed. So, this is the wrap around facing. So, vertical facing of the reinforcement generally 0.3 to 0.5 meter, and it is required to protect the geotextile against the ultraviolet light or degradation or vandalism and damage due to the fire. In such case, that shotcrete should be applied to the wall facing. Here the shotcrete should be applied to the wall facing. This may be the geotextile woven and non-woven geotextile material. This is wrap around facing. You can see this is the segmental precast concrete block, and this is the number of layer of the GeoGrid material. This may be the high density polyethylene GeoGrid or non-polyester GeoGrid also. So, here is the segmental precast concrete block. This is the block. So, high density polyethylene GeoGrid are casted into the panel during the manufacturing process in the field. The main GeoGrid is then connected to the high density polyethylene GeoGrid, which we can say that Bodgin joint, we call Bodgin joint, which is about 30 centimeter away from the facing element. The flexible polyester GeoGrid should not be casted due to the high alkalinity in the presence of wet concrete. So, one has to be very careful that what kind of the material should be casted with the concrete. You can use the high density polyethylene GeoGrid material, but not the polyester GeoGrid material, because for its high alkalinity presence in the wet concrete. So, three types of the precast concrete face panel. This is hexagonal shape panel. It may be 1.5 meter height, 1.75 meter width and 0.165 meter thick. Or rectangular panel, it may be 3.81 meter long, 0.61 meter height and 0.2 meter thick. Or T-shaped panel, it may be 3.2 meter area and 0.16 meter thick. So, you can have the different types of the facing element. Now, when this GeoGrid, in axial this GeoGrid you wanted to join, so this joint also it called the Bodgin connection joint. Here is the Bodgin connection joint. Here you can see that this is the 4-bar concrete epoxy coated steel, and this is 20 centimeter, and this is the front face, and this is 7.5 centimeter cover minimum required, and this is the GeoGrid embedment 7.5 centimeter, this is minimum required, and this is the GeoGrid material, high density polyethylene GeoGrid material, which is away from the facing element about 30 centimeter, and then you can join here with the remaining GeoGrid material, and this here it is a Bodkin, and this Bodkin joint, a rigid PVC pipe is used as a Bodkin. This is a rigid PVC pipe which is used as a joint, and there should not be any slack in the connection. So this way you can join this material. This is full height concrete panel. This is absolutely this full height concrete panel. This is the number of the layer of Geogrid reinforcement. Now full length concrete panel are 12.5 centimeter to 30 centimeter thick, and 240 centimeter to 300 centimeter wide, and 750 centimeter in height. Steep polyethylene geogrid are casted into the panel similar to the segmental precast concrete panel, and the minimum compressive strength of the concrete at 28 days is 27.56 MPa. So you should maintain this strength. Now this modular concrete block wall. So this is the modular concrete wall facing, and this is the number of the layer of the reinforcement material, and this block has a length about 200 millimeter to 600 millimeter, and height is about 100 millimeter to 200 millimeter, width is 200 millimeter to 0.6 millimeter, and the weight of the die casting modular block wall is 15 kg to 50 kg. So this is the kind of the modular concrete block. So you can place the modular concrete block, and then you can place the geogrid material, and which should be connected with this block, and then you place the another block, and then there are different types of the joining system. I will show you later, and then like that you can construct the modular concrete block wall. And because this block is weight about 15 kg to 50 kg, so it is very easy to handle, and you can construct the mechanically stabilized reinforced block wall using this modular concrete blocks. Now the gabion facing wall. So gabion also can be used as a facing element. So this is the gabion. You know the 1 meter cube galvanized mild steel. Okay, this will act as a gabion, and this gabion you can place one by one, and then you can place this reinforcement which can be connected with the gabion. So gabion is a kind, a basket made of the galvanized mild steel wall mesh and polymer geogrid filled with the rock or the stone. So this also will act as a facing element. So gabion also act as a facing element. There are many like that. Timber facing also has been used in US, where there is a locally timber is available. So they provide with the timber and then wrap with the geotextile material like this. So you can construct the wall as a timber as a facing. You can also welded wall mesh facing. Sometimes you can place with the geogrid material like that, and you cannot keep it open, and then you can provide with the welded wall mesh here. You can provide with the welded wall mesh, and then later on grass can grow, so it looks also greenery. The welded wall mesh also has been used in various projects. Also guni bag facing. This is a kind of the guni bag. So, and this is the geotextile material, and this wrap it like this. So this is the guni bag is act as a facing element. The brick also has a facing wall. This is the brick. You can place the brick, and then the number of the layer of the geogrid material. So what brick also will act as a facing element. Now there are different precast concrete modular block or panel facing and connection. You can see this is the sum of the modular concrete block for segmental retaining wall after Bathyres and Smyke's 1994. You can see this is a kind of the block, and you can see that there is a hole here. This is act as a facing element, and this hole is filled up with the aggregate which will act as a drainage. So you need the proper kind of the drainage at the facing element. Apart from the back and the bottom and the top, you also require the proper kind of drainage at the facing. So where this will act as a facing element. You can see that some block here he can place the GeoGrid material here, and then he can place the another block. So there are different types of the block, the way you like. He can see here also where it can act as a drainage, he filled up with the aggregate. So there is a connection how you have to connect one modular block with the another modular block. And this kind of the block generally weight about 15 to 50 kg, and it is very easy to handle. Now this slide shows some GeoGrid connected with the modular block either mechanically or by the friction, or after Simex ETL 1993. You can see here is the CR pin. Okay, this is the hollow core and filled with the crushed stone or the drainage. This is the GeoGrid material, and this is the precast concrete block where it act as a CR pin. Here the CR key, you can see like this, GeoGrid material placed like this and like this. So here it can act as a CR key. Here it can act as a CR pin, here act as a CR key. And sometimes also you can go leading CR lip like this, CR lip like this. So this GeoGrid connected with the modular block, either the mechanically or the friction. So here slide you can see that how it is the friction is connected here. This is the one modular block. You can see the size about 20 centimeter to 40 centimeter, and this is the GeoGrid material, and there is a hook. You can see there is a hook, and the GeoGrid material pass through this, and then you can place the another block here, and which it will act as a facing element. So this is the frictional connection, and you can provide the drainage about 30 centimeter here, or aggregate, or you can provide with the GeoTextile or the any geocomposite drainage material also. And this is the I show the mechanical connection. This is mechanical connection. This is the facing, that is the timber, this is the spike, and then this is the GeoGrid material. This is compacted the reinforced soil, and this is drainage aggregate as it is in the frictional clays where it can be mechanically connected. So more about this you can see here that cross sectional view of the horizontal joint. This is about detail about the A, and you can see here 3.2 centimeter, and this is the front face of the panel, this is the rear face of the panel, and this is 21 centimeter. It's like this you can see detail of the A, and this is the GeoGrid material, and this is the segmental panel. So this is the detail of frictional connection between the GeoGrid and the segmental panel. I am showing that some of the construction detail. You can see the different types of the block, how it has been placed here, and you can see the wall how it is constructing, and this is filled up with the aggregate. It will act as a drainage. This is the block. So it is a small block, and the weight is not so much, so one can carry and can fix it up, and then you fill up with the aggregate for the drainage. You can see how this GeoGrid material has been placed and how it is connected, how the block is also placed. This is a general view of wall during the construction. You can see how the placing of the facing block one with the other. You have to place the properly, the lips should be proper, it should be joint, it should be connected, the GeoGrid material with the block in proper placing. You can see wall ties existing the provided with the false spacing element here. So now we require for the analysis and design reinforced for geosynthetics reinforced soil retaining wall. These are geosynthetic reinforced soil wall with inclined surcharge load. Sometimes it may be the incline, sometimes it is not inclined. If there is a incline, then you have to be considered what will be the surcharge load. Here you can see Q is the surcharge load, which is making at an angle of beta, and this is the slope field. And as I say, this is the reinforced field. You always remember this is the reinforced field, and this is the length of the reinforcement is L, and this is the foundation soil, and this is the geosynthetics reinforced return field, and this is the facing of the wall, and this is the depth of the abandonment. We will design this mechanically stabilized reinforced soil wall, and there is a possibility for any the seismic forces, that also we will take into account. So here this slide showing that what is the geosynthetics reinforced soil wall with inclined surcharge load. This is some schematic view of segmented reinforced soil retaining wall, and what it is HM here. You can see this is the anti that cross barrier. Here is the cross barrier, and here this you call the coping, and because this kind of the barrier is needed when this is the road. So in a road we can, as usual, you know that how to design the road, or you require for the BC, bituminous coated, or the DMB, dense bituminous macadam, or WMM, or the GSB. So you can design this. You can provide sometimes here also with the addition of the GeoGrid reinforcement, which can reduce the thickness of the pavement, and you require a proper kind of the cross barrier, because sometimes when there is an accident, the car can attack this barrier, so it can be prevented. So this also you require proper kind of the design, though sometimes it is related with the structural analysis, but we will deal mainly on the design of the GeoGrid reinforced soil retaining wall, where HM here is the mechanical height, and HF this is the facing height, and HD is the design height. So whatever you can see the reinforcement is passing through this, okay, this is the reinforcement height. So height of the design for this up to this, that's why we say it is the design height. And also when we will use either the block or the, then it requires certain kind of the wall barrier. You cannot construct the absolutely the vertically, you can make some kind of the wall barrier. And precast concrete segmented facing panel, and which criteria will be the M35, that concrete grade is required. Also at the base you require the level padding. First of all you have to construct a level padding, and which the length will be about 600 millimeter, and this also will be the 200 millimeter, and you have to provide with the minimum embedment depth, which will be about the 1200 millimeter. And then you provide this what will be called the drainage system. This is the retain field, and this is the geocomposite material which will act as a drainage, and you provide with the perforated pipe and wrapped with the geotextile material. So when you will design this kind of the segmental reinforced soil retaining wall, you require that many properties of this material. You require properties for the foundation soil, which can be designed at the gamma 8, pi f and cf. You should know what should be the unit weight of the foundation soil, what will be the friction angle of the soil of the foundation soil. You should know what will be the cohesion of the foundation soil. Similarly, you should know that what will be the properties of the retained soil. That means it will be a gamma b, what will be the unit weight of the retained soil, or what will be the friction angle of the retained soil, what should be the cohesion value of the retained soil. Similarly, you should know what should be the characteristics of the soil in the reinforced field material, what you require, what will be the unit weight of the soil in the reinforced soil zone, what should be the friction angle of the soil. And at the same times you require that proper kind of the drainage system, and what kind of the drainage system you should consider in your design. Now step 1, you require physical characteristics of the mechanically stabilized soil wall. So you require first that what will be the wall geometry. you should know what will be the height of the wall, is designated as h, what will be the length of the wall, that is the length L, what will be the wall face, better angle, that alpha. And generally the wall require a normal better of 3 to 10 degree centigrade. Most of the cases you can use also the 5 to 6 degree. And slope angle of the soil surface, that I, that required if there is any slope. If there is no slope, then that is 0. And you should also consider that what should be their loading. That means it is a surcharge load. If there is a live load, is equal to QL. If there is a dead load, is equal to QD. So total surcharge load you have to take into consideration, which will be the summation of the live load and the dead load. Now, what is the type of the facing? It may be full height concrete panel, then wrap facing, or modular or segmental concrete block, or Gravion facing. And you should know the what will be the vertical facing of the reinforcement, SB. If it is a wrapping system, so maximum spacing SB is 0.5 meter to 0.6 meter for geotextile. It may be the oven geotextile or it may be non-oven geotextile. And sometimes also you can use GeoGrid as a wrap face wall. Now, precast concrete face panel, the spacing of the GeoGrid reinforcement may be kept from 0.5 to 1 meter. However, it is recommended to keep the vertical facing of the reinforcement as 0.6 meter to 0.8 meter. Of course, it depends upon that what will be the thickness of the modular block, or what will be the height of the modular block, or what will be the height of the panel. So accordingly, we have to be provide with the vertical spacing, whether it is a 0.6, whether it is a 0.7, whether it is a 0.75, whether it is a 0.8, and sometimes it may be the 1 meter. But it is recommended that spacing of the reinforcement should be lie between 0.6 to 0.8 meter, which will be very reasonable. Now, modular block, for the modular concrete block of height 200 millimeter to 250 millimeter, the spacing of the reinforcement may be 200 millimeter, 400 millimeter, 500 millimeter, 600 millimeter, 750 millimeter, 800 millimeter, and even then 1 meter. Now, for segmented concrete block, if the spacing is more, then use the secondary reinforcement. And vertical facing of the reinforcement depend on the strength of the reinforcement, what will be the facing connection, and the type of the panel or block used for the construction. Because most of the cases failure can come about in the numerous way. There will be a GeoGrid, there will be the tension failure, there will be GeoGrid, there will be the connection failure, there will be the GeoGrid, there will be the slipping, or sometimes that block, modular block wall, the fail. So you have to establish the preliminary wall dimension. A minimum length of the reinforcement as per FHW 2009. That case A, if it is a static loading without or with traffic surcharge, the minimum length by height ratio is 0.7. This is as a thumb rule for any design in the beginning. If you can start, you can use to length to height ratio will be equal to 0.7. Then you can continue with design and check. Or if it is a sloping backfill surcharge, then minimum length to height ratio will be 0.8. If it is a seismic loading, then minimum length to height ratio is 0.8 to 1.1. Now B, for wall founded on slope, a minimum horizontal bench of 1.2 meter wide should be given in front of the wall. Minimum embedment depth should be 0.5 meter. Minimum 1 meter embedment length is recommended beyond the ranking failure wedge for pull-out resistance. Step 2, evaluate the engineering properties of the foundation soil. Detailed soil exploration has to be carried out along the alignment of the reinforced soil wall at every 25 interval. It is necessary to carry out the test. Sometimes you can obtain some result without any soil exploration. It will be a danger. So it is very important that one should carry out the test along the element of the reinforced soil wall and every 25-meter interval. And you have to evaluate what will be the gain side distribution curve, what will be the moisture content, what is liquid limit, plastic limit, shrinkage limit, and plasticity index of the soil. And you calculate the shear strength and the consolidation parameter of foundation soil and check the location of the groundwater table. So these are very common that what has to go for the soil testing. Step 3, evaluate the reinforced field and retained backfill soil. Check the gain side distribution and the plasticity index. Plasticity index should not exceed 6 as per ASTO T90. Coefficient of uniformity of the reinforced field should be greater than or equal to 2. Organic content should be limited to 5%. And determine the optimum moisture content OMC, maximum dye density or relative density with the aid of standard Proctor test. And minimum compaction of the backfill soil should be 90% of maximum Proctor density. So you should maintain that density. If you don't maintain that density, if you don't properly compact the soil, then there is a possibility for the failure of the reinforced soil structure. Then internal friction pyre of the soil is the reinforced zone can be determined from the drain direct shear test. For retained backfill, the internal friction angle pi b can be determined by drain triaxial compression test or direct shear test. Generally, the angle of internal friction should be less than or equal to 34 degree. Coefficient of permeability should be greater than or equal to 1 into 10 to the power minus 2 centimeter per second. No cohesion should be considered. That is, fine silt and clay should not be used for reinforced field. Appropriate drainage system is required at the back, base and front of reinforced soil retaining wall. If the quality of the backfill is poor, the adequate drainage cannot be achieved. That is in 2007 as mentioned. For polyester geosynthetics, pH value of soil should lie between 3 and 9, that is Elsevier Christopher 1997. For polyethylene or polypropylene, pH of soil greater than 3, ASTO T28991. Minimum aperture size of the geogrid should be greater than 3.5 times the particle size of the backfill soil as given by Sasby 1985. In many cases, we use the minimum average roll value MARV obtained from the manufacturer certificate. For good design, good construction, it is recommended to verify the test result of geosynthetic material from the third party. Gradation of the backfill soil of reinforced soil zone, wall slope after Koina detail 1993, GSI and GRI. This is very, very important because most of the time if we do not select the proper kind of the gradation of the soil material, then there is a possibility for the failure. So as for this SIP number 4, 10, 15, 40, 100 and 200, the particle size lies between this and percentage of passing will be this. But you can see in case of FHW, this adopt this 50% passing in 200 SIP. Whereas NCMA adopt 35% of passing or 200 SIP. So sometimes most of the cases that FHW also is follow up, but this Koina recommended this for 0. So when you will use this kind of the backfill soil material, so you have to select proper kind of the gradation of the material. The another factor is the creep reduction factor for polymer. This is also very, very important. FHW NH1 10024 2009. It depends upon the what will be the polymer type. It is a polyester PET or polypropylene PP or high density polyethylene HDP. You can see that how the creep reduction factor vary 2.5 to 1.6 for polyester, for polypropylene 5.0 to 4.0 and for high density polyethylene 5.0 to 2.6. So here is the one point to keep, to remember that what will be the keep factor and what kind of material you should use, whether it is a polyester, polyethylene or high density polyethylene. If the keep reduction factor is more, and then your allowable bearing capacity, allowable tensile strength of the GeoGrid material also equally reduced. On the other hand, if you use the polyester material whose keep reduction factor is less, so in that case the allowable tensile strength of the GeoGrid material will be on the hard side. So that was one of the reasons that sometimes that polyester material is the better than the polypropylene and high density polyethylene material. But whatever it may be, you have to be very careful for the keep factor and what kind of the material you want to use it. So with this I ended up this lecture today. Thank you very much.